Audio Jungle.
Welcome to today's lesson. Today we'll be looking at electrical conductors and insulators. Now, what is conductors and what is insulator? Conductors are those materials that allow electricity or electrons to pass through them. While insulators are, on the other hand, materials that do not allow electricity or electrons to pass through them. Okay, so they have a very high resistance. They resist the flow of electrons or electricity. But why do some materials resist electricity and some do not? It's because of their atom. We said every atom consists of proton, neutron, electron. Okay, is it not? Yes. And we said the neutron and the proton are joined together to form the nucleus, while the electron are moving around the nucleus. Yes. In a conductor, that is a material that allows the electron to flow, the atoms are very free. Okay, the electrons of the atoms are very free, so they are easily pushed when there is a voltage, is it not? Yes, you can see it from this diagram I'm showing you now. There is free space for the electron to flow through. That is in a conductor. All right, there is always free space for the electron to pass through. Unlike insulator, in an insulator, all the atoms are joined together. Okay, there is no free space. They are joined together. They are all bonded or joined together. So there will not be free space for electron to be pushed easily. You can see it. Is it not? Yes, electron wants to pass through now. There is no space. Why? Because they are joined together. There is obstruction. So we say this kind of material are insulator and they have a very, very high resistance. Do you get it now? Yes. From these drawings now, we can easily say that insulator, they resist the flow of electrons or electricity. That means I can say good insulators are very, very bad conductors, while good conductors are very, very bad insulators. Why? Because they do the opposite. Is it not? Yes. Let's now look at some materials that we can classify as insulators or conductors. Materials you can have, there are various types or kinds of material, but we'll look at some of them right now. We'll look at the first one. We have this plastic. We'll look at metal. We'll look at rubber. We'll look at cloth. We'll look at paper, and then we'll look at wood. All these are examples of materials. Now, generally, when we want to talk of conductors and insulators, we can classify these materials to be electrical conductors or electrical insulators. Metals are mainly electrical conductors. For example, you can see silver there. Okay, silver is the most conductive or known material or metal. That is, it has the lowest of resistance. It allows current to pass through it very easily compared to gold and copper and aluminum and the rest. All right. Then if you look by my down, we have insulators. What I say? We have insulators. So all these are examples of insulator. Your rubber, your glass, your oil, your diamond, okay, and your dry wood. They are all examples of insulator. We can demonstrate this using a circuit. I already told you what a circuit is. What is a circuit? A circuit is a connection or a system that has a voltage or an electric source, a line, and then a load, and also a switch. In this one, we remove the switch and we use a alligator clip. Okay, because we want to demonstrate which material will conduct electricity and which material will not conduct electricity. This alligator clip has a metal on it, so it lights the bulb up. Okay, so now we'll remove the alligator clip and then we'll test it with some of those materials we mentioned earlier to know if they will conduct electricity. You have to demonstrate this experiment in class when you are building your circuit. All right, so we'll pick up the materials that we use. First, we go with the a metal spoon. You already know a metal spoon can be made from gold, copper, iron, and even what? Silver. Okay, so if I put it, current will flow through it. Why? Because there is free space for the electron to what? Pass through. Is it not? But if I put a book, on the other hand, the bulb will not light up. That means current will not pass through it. It's an insulator, is it not? Yes. There's no space for electron to what? To be pushed easily. Is it not? Yes. So look at the paper clip. The paper clip is also made with metal. Alright? So if I put a paper clip, current will what? Flow through. Or electrons will what? Flow through. Take note, the electron will always flow through because we're using a battery from the negative what? To the positive. Is it not? Yes. Connecting what? A towel. The towel is dry, it's not wet, so we're not going to have what? Any light. Why? Because it's an insulator. It does not allow what? Electron to pass through it. Okay? So it's a bad conductor. Alright, and we look at connecting a metallic ruler. Okay? A metallic ruler is made of metal. It will allow what? Current to what? Flow through it easily. Okay? Yes, because it's made of what? Ruler. You get it now? Yes. Then we'll connect an eraser. An eraser will be made with what? Plastic. Okay? If we put an eraser, plastic are all good insulators. Okay? It will not allow current to pass through it. They are bad conductors. Alright. From this deduction, you now see that materials that are made with metals are what? Conductors. While those that are made with non-metals are what? Non-conductors. I want you to sit back, watch this video, and still learn more about how to experiment this because we are going to demonstrate this in class.
Is take a look at some different objects. We have some metals, some plastics, a Sharpie. How about a pickle and some water? We will hook it up to some electricity and see if it is a conductor or an insulator. Up first, we have copper. Hook it up, and yes, it's a conductor. How about this piece of plastic? Flip the switch. Nothing happens. It is going to be an insulator. Now we move on to another piece of metal. It's aluminum. Flip the switch, and yes, it is a conductor. Now, how about some wood? Hook it up. Flip the switch. Nothing happens. So it is an insulator. After the block of wood, let's try this. How about we try a Sharpie? It's plastic. It's hooked up. We go to the switch, and nothing happens. So it is an insulator. How about this? Let's try some water. I've got two nails hooked in. I flip the switch. Nothing happens. Well, let's modify the water slightly. Let's add some salt. As I add the salt, I pour it in. I go back to the switch. What do you think? Is it going to change? I hit the switch, and yes, it is now a conductor. The salt allows the electrons to move freely. Next, let's try this screwdriver. The reason why I use this, I have plastic on one end, metal on the other. I flip the switch, nothing happens. But now, if I move it to where it is touching metal only, it's now a conductor. So the plastic helps insulate it. How about this? How about the pickle? It has a lot of salt in it. Well, I don't know about that. I plug it in. It smokes a lot. It glows. But I would consider it an insulator. How about celery? It kind of tastes salty. Maybe it has enough salt in there. I plug it in and, well, you can see for yourself. Nothing really happens. Well, it does start smoking a little bit. So let's see what happens with the celery with 110 volts going through it. Smoking, but it is an insulator. It's kind of cool looking though. Next, how about the apple? It's kind of a dud. Well, not really. It's an insulator. So if you need to insulate, an apple is your object.
Welcome back from that video. I believe you now know what an insulator is and what a conductor is. You know why certain materials conduct electricity and why others do not conduct electricity. Is it not? Yes, I now know examples of insulators and what? Conductors. And you now know how to demonstrate if a material is an insulator or if a material is what? A conductor. That now brings us to the end of today's lesson. Remember to take your quiz. Have a nice day and take care of yourself.